Hello. In this video, I will go over how to convert metric system to the household system and vice versa, household system to the metric system. So, yeah, we are definitely converting from between metric and household and vice versa. So, um, in your notes, you can write down these notes or you could download the documents, but excuse me, you can just write it down and then yeah, write these conversions. So in your notes, 1 kilogram is equal to 2.2 pounds. 30 milliliters equals to 1 fluid ounce. 15 milliliters equals to 1 tablespoon. 5 milliliters equals to 1 teaspoon. And 2.5 centimeters equals to 1 inch. So go ahead and copy that down because we're definitely going to use these. Okay, let's start with example one. So we're going to do two methods, the dimensional analysis and ratio and proportion. So in example one, we have to figure out how many, we have 132 pounds equals to how many kilograms. So let's start with dimensional analysis. So you write it out when you write it as a fraction. So 132 lbs times, and then fraction pounds units on the bottom, and then kilogram units on the top, right? And we know that 1 kilogram, there's exactly 2.2 pounds. Okay. And then the pounds disappears, and then the units you multiply across. So it's going to be 132 times 1. And then on the bottom, what's 1? It's 1 times 2.2. So when you put it all together, 132 times 1 is 132. And then 1 times 2.2 is 2.2. And when you put in the calculator, you get exactly 60 kilograms. And yes, you must include this zero because 60 is not the same thing as 6, right? That would be wrong. Okay. So yes. And then ratio and proportion, how do we set it up? We set it up like this. And if you recall ratio and proportion, you can set it up any way you like, as long as the numerator matches the numerator on the other side and the denominator matches on the other side of the denominator, right? So you could put pounds on the top, kilograms on the bottom, and then pounds on the top, and then kilograms on the bottom. So we were given 132 pounds, that was given. We're trying to figure out kilograms, that's our unknown, and we should only have one unknown. If you have two unknowns, you have to do some conversions. And then what is the relationship between pounds and kilograms based on the chart that you just wrote? We know that 1 kilogram, there's exactly 2.2 pounds. Okay, so go ahead and cross multiply. So this is going to be 2.2x equals to 132 times 1. And you get 2.2. X equals to 132. Divide this by 2.2, 2.2, and you get 60 kilograms. Okay, example two. We have to convert 7 fluid ounce to milliliters. So let's start with dimensional analysis. So write out your fraction. So 7 fluid ounce times fraction, and then you want to get rid of the fluid ounce. You put fluid ounce on the bottom, and then we're trying to figure out milliliters. So put milliliters on the top, and then you put at 1 under the 7 fluid ounce. And then what is the relationship between milliliters and fluid ounce based on the chart? Well, we know that for 1 fluid ounce, there's 30 milliliters. That was said on the chart, right? And then the fluid ounce units disappear. That's what you want. You want your final answer to be milliliters. And when we're multiplying fractions, you multiply across. So it's really on the top, it's 7 times 30. And then on the bottom, it's 1 times 1. And 7 times 30 is 210 milliliters. And yes, you must include this trailing zero because that is not the same thing as if you didn't include that zero, that would be 21, which is completely wrong, right? Okay, set it up as a ratio and proportion. So let's set it up as a fraction. So you can set up any way you like. So on the top, you could do fluid ounce. And then on the bottom, you could do milliliters. And then over here, you could do fluid ounce. And on the bottom, milliliters. So we were given 7 fluid ounce, and then our unknown was milliliters. And then based on the chart, what is the relationship between fluid ounce and milliliters? Well, we know that 1 fluid ounce, there is 30 milliliters. Okay, cross multiply. So x times 1 is x. And then 7 times 30 is 730. 7 times 30. And that gives you 210 milliliters. Okay. Example 3, we have 40 milliliters and we need to know how many teaspoons. So let's start with dimensional analysis. So fraction, 40 milliliters times fraction, and then milliliters on the bottom and teaspoon on the top, and then put in invisible one. So what's the relation, based on the chart, what is the relationship between milliliters and teaspoon? Well, according to the chart, for 1 teaspoon, there's going to be exactly 5 milliliters. So you can see the milliliters units disappear, and then you're left with teaspoon. That's what we want. And then this is a fraction, so multiply across. So if it's 40 on the top, it's 40 times 1. And then on the bottom, it's 1 times 5. And that's 40 over 5, which is 8 teaspoon. Now remember, need to add, you don't have to add trailing zero if there isn't any decimal. And you don't need, you don't need to add leading zeros if there's no decimal. And you definitely don't add trailing zero. So it would be wrong if it was 8.0. Okay, ratio and proportion. So let's set it up as a fraction. So you could put milliliters on the top and teaspoon on the bottom, milliliters on the top and teaspoon on the bottom. So we were given exactly 40 milliliters, and then our unknown was X. And then what's the relationship between milliliter and teaspoon? So 5 milliliters, there's 1 teaspoon. For 1 teaspoon, there's 5 milliliters. And then cross multiply, so that's going to be 5x equals to 40 times 1 is 40. Solve for x, so you're going to divide this by 5, divide this by 5, and then 40 divided by 5 is 8. Okay, sample 4. This one we have to figure out 5 foot 4 inches equals to how many centimeters. So this one we have to do just an extra step. We have to that one of the directions says also round to the nearest whole number. So usually you round to the nearest tenths, but this problem says round to the nearest whole number. Okay. So what we have to do is first convert everything into inches because uh we can't, this isn't foot and this isn't inches. it wouldn't be right if we convert everything to foot, right? I think it's just easier to convert everything to inches. So first convert everything into inches. How do we convert 5 foot into inches? So it's going to be 5 feet. What is the same thing as feet, right? Times, and then feet on the bottom and inches on the top, right? So for 1 foot, there's 12 inches, and feet disappears, and you're left with inches. And then you just multiply across. So 5 times 12 over 1, and then 5 times 12 is 60 inches. Okay. And then you add that 4 inch. So that is a total of 64 inches. Okay, now let's do so now we have to come, we're not, that's not our answer because we want it in centimeters, so we got to do dimensional analysis. So it's going to be 64 inches times fraction inches on the bottom and then centimeters on the top and then invisible one. So what is the relationship between inches and centimeters? We know that for 1 inch, there is 2.5 centimeters. And inches disappears and then multiply across. So 64 times 2.54. And your final will be in centimeters. And the answer says, I mean, the question says round to the nearest whole number. So when you put it in the calculator, you get like a decimal. You get like 162.56 centimeters. So I don't care about the others because this is the number I care about. This two represents the next whole number. So this is what you do, and then you look at the neighbor. If the neighbor is five and beyond, you do have to round. So this is 5, so you do got to round. So it's going to be 163 centimeters. Okay. Okay, let's set it up as a ratio and proportion. So let's see. We already convert everything to inches, so let's put it inches on the top and centimeters on the bottom, and then inches on the top, centimeters on the bottom. So we were given 64 inches, and then we don't know our centimeters, so we'll call it X. And then what is the relationship between inches and centimeters? Well, we know that for 1 inch, there is 2.54 centimeters. Okay. And then cross multiply, so that's X equals to 64 times 2.54. And that gives you what? 162.56. When rounded, because it says round to the nearest whole number, it's 163 centimeters. Okay, example 5 kilograms converts to how many pounds? And the direction says round to the nearest hundreds. So hundreds place is not the same thing as whole numbers. So this one, you don't have to convert. It's not like a two-step like the other one. So you can start with your dimensional analysis. So we were given 5 kilograms times fraction, and then kilograms on the bottom, pounds on the top, and visible 1/5. And then what is the relationship between pounds and kilograms? We know that for 1 kilogram, there's exactly 2.2 pounds, right? And then the kilograms disappears and then multiply across. So you have 5 times 2.2, and then on the bottom it's 1, and you get 11 pounds. Now I know the direction says round to the nearest hundreds. Shouldn't we add 0.00? Shouldn't we say 11.00? No, we do not add these trailing zeros, right? I mean, yeah, we do not include trailing zeros ever. Okay. Okay, ratio and proportion, so we're going to set it up as a fraction. Let's see, kilograms on the top, pounds on the bottom, kilograms on the top, and then pounds on the bottom. Or you could do vice versa, pounds on the top, kilograms on the bottom, but that means this has to be pounds on the top, kilograms on the bottom, right? So we were given 5 kilograms. We're trying to find pounds, which is our unknown. And what is the relationship between kilograms and pounds? We know that based on the chart, 1 kilograms, there is exactly 2.2 pounds. Okay, go ahead and cross multiply. So that's 1 times x is x, and then it's 5 times 2.2. As you can see, you get 11 pounds LBS. Okay, let's move on to example 6. Okay, we have in example 6, we got to convert 14 pounds and we got to convert it to kilograms. And the direction, I can't believe I didn't read this, but the direction says round to the nearest hundreds. Okay, so let's write it as a dimensional. So 14 pounds, 14 lbs times fraction, and then lbs on the bottom, and then kilograms on the top, and invisible one under the 14. So what is the relationship between kilograms and pounds? Well, we know that for 1 kilogram, there's 2.2 pounds, and then that pounds disappears. We're left with kilograms, and then just multiply across. It's 14 times 1, and then on the bottom, it's 1 times 2.2. So 14 times 1 is 14, and then 1 times 2.2 is 2.2, and you get 6.36 kilograms. Uh, Actually, it was like 6.3636, but the direction says round to the nearest hundred. So here's 6 would be the hundreds place. You look at the neighbor, 3 is not 5 and beyond, so it's why I kept it as 6.36. Okay, ratio and proportion. So set it as a fraction. You could put pounds here on the top, kilograms on the bottom, and then pounds on the top, kilograms on the bottom. We were given 14 pounds, and then kilograms is our unknown, and then 2.2 pounds, and then 1 kilogram. Okay, go ahead and cross multiply. So it's 2.2x equals to 14 times 1. That's 2.2x equals to 14. And then divide this by 2.2, and you get 6.3636. That's 6.36. Example 7, we have 3.6 kilograms converts to pounds, round to the nearest hundreds. So let's do that. So we were given 3.6 kilograms times fraction, kilograms on the bottom, pounds on the top. So invisible one on the bottom. And then what's the relationship between kilograms and pounds? Well, from 1 kilogram, there's 2.2 pounds. Kilograms disappears, and then you're left with pounds. And then you just multiply across, so that's 3.6 times 2.2. And then on the bottom, it's 1 times 1. And you get 7.92. 7.9 something. Well, because this, um, let me be exact. Or is that exact? Let me check. Because I already done this 3.6 times 2. Yes, it's exactly 7.92. There's no other numbers, but it says round to the nearest hundreds. We're fine because 2 is the hundreds place, so we don't have to go any further. So my final answer will be 7.92 pounds. Okay, ratio and proportion. So we'll set it up as a fraction. You could put kilograms on the top, pounds on the bottom, kilograms on the top, pounds on the bottom. So we were given 3.6 kilograms, and then our pounds was unknown. And then what's the relationship between kilograms and pounds? Well, we know that for 1 kilogram, there's exactly 2.2 pounds. Okay, cross multiply. So 1 times x is x, and then it's 3.6 times 2.2. And when you put it all together, you get 7.92. Example 8. We are given 156 pounds converted to kilograms, round to the nearest hundreds. So dimension analysis. Okay, so we start with 156 lbs times fraction, lbs on the bottom, kilograms on the bottom, on the top, right? And then invisible one on the bottom. So what is the relationship between kilograms and pounds? Well, we know that for 1 kilograms, there's 2.2 pounds. And go ahead and the pounds disappears, and then you're left with kilograms and multiply across. So 156 times 1. Then on the bottom, it's 1 times 2.2. And when you put it all together, you get 70.90909. But the direction says round to the nearest hundreds. So this 0 would be the hundreds place. You look at the neighbor, which is definitely 5 and beyond. So you do have to round it to 70.91 kilograms. That's it. Okay, ratio and proportion. Okay, so you could put pounds on the top, kilograms on the bottom, pounds on the top, kilograms on the bottom. So we were given 156 pounds, and then kilograms is unknown. And what is the relationship between pounds and kilograms? Well, we know that 2.2 pounds is for 1 kilogram. Okay, go ahead and cross multiply. So this is 2.2x equals to 156 times 1. So that's 2.2x equals to 156. Divide this by 2.2, and you get 70.91. Okay, example 9. We have 28 kilograms converts to how many pounds? The direction says round to the nearest hundreds. Okay, so let's do the dimensional. So we were given 28 kilograms times fraction, kilograms on the bottom, and then pounds on the top. Okay, what is the relationship between, oh, you can put an invisible one. But what is the relationship between kilograms and pounds? Well, we know that for 1 kilogram, there is 2.2 pounds. And then the kilograms disappears. And then you multiply across. So 28 times 2.2. And then on the bottom, it's 1. And when you put it all together, you get 61.6. Now, the direction says round to the nearest hundred. This is our final answer. It would be wrong if you say 61.60. Why is this wrong? Because even though it says round to the nearest hundreds, and zero is definitely in the hundreds place, zero is a trailing zero, and we never include that. Okay, so your final answer is 61.6 pounds. Okay, ratio and proportion. Um, kilograms, pounds on the bottom, kilograms, pounds on the bottom. You were given 28 kilograms, unknown pounds, and then the relationship between kilograms and pounds. We know that for 1 kilogram, there's 2.2 pounds. Cross multiply, so that's x equals to 28 times 2.2, which is 61.6. Example 10. We have 225 pounds converts to how many kilograms? The direction says round to the nearest hundreds. So yes, let's do this one. So dimensional analysis. Start with 225 pounds, fraction, pounds units on the bottom, kilogram units on the top, invisible one under the 225. What is the relationship between kilograms and pounds? Well, according to the chart, for 1 kilogram, there is 2.2 pounds. Okay, the LBS units disappears, and you're left with kilogram. Since this is fraction, multiply across. So on the top, it's 225 times 1, which is 225. And then on the bottom, it's 1 times 2.2. Put it all together, you get 225 over 2.2, and you get 102.2727. Round to the nearest hundred. So 7 is the hundredths place. 7, you look at the neighbor. 2 is not 5 and beyond, right? So you just round it to 102.27. Okay, ratio and proportions of fraction, and then you can put pounds on the top, kilograms on the bottom, pounds on the top, kilograms on the bottom, right? So we were given 225 pounds. Our kilogram was unknown. Um, for 1 kilogram, there's 2.2 pounds. Cross multiply, so this is 2.2x equals to 225 times 1. That's 2.2x equals to 225. And then solve for x, you're going to divide this by 2.2. And that gives you 102.27. Okay, example 11. We have 4 feet and 2 inches converts to how many centimeters? Round to the nearest hundredth. So yes, first what we got to do is this is like a two-step. You must convert everything to inches. Okay, so let's do that. Let's convert that feet into inches. So 4 feet times fraction, feet on the bottom, inches on the top, invisible one on the 4 if you want. We know that for 1 feet, there's 12 inches. The feet disappears and then multiply across. So 12 times 4 is 48 over 1. So that's 48 inches. But we also have that additional 2 inch. So what's 48 plus 2 inch? It's 50 inches. Okay, so in total, 4 feet and 2 inches is the same thing as 40 inches. So start with dimensional analysis. So 50 inches times fraction inches on the bottom, centimeters on the top, and then invisible one. So what's the relationship between inches and centimeters? Well, for 1 inch, there's 2.54 centimeters, and then multiply across. So 50 times 2.54 over 1. And when you multiply this out, you get exactly 127. Now it says round to the nearest hundreds. Wait, so what's my units? Centimeters. It says round to the nearest hundred, but do we include 1.2.00? No, don't, because we don't include these zeros. Ratio and proportion, and then so ratio proportion, you put inches on the top, centimeters on the bottom, inches on the top, centimeters on the bottom. So we know that there was a total of 50 inches, and then centimeters unknown. And then we know that for 1 inch, there's 2.54 centimeters. Cross multiply, so 1 times x is x, and then you have 50 times 2.54. And when you put it all together, you get 127 centimeters. Example 12, we have 10 centimeters converts to how many inches? Round to the nearest hundreds. So we'll start with dimensional analysis. So we have 10 centimeters times fraction, centimeters on the bottom, inches on the top, fraction, and then for 1 inch, there is 2.54 centimeters. And then the centimeters disappear. 10 times 1 is times 1 is 10. And then on the bottom, it's 1 times 2.54. You get it? It's 10 over 2.54. And when you put that in the calculator, you get 3.93700. It says round to the nearest hundred, so 3 is the hundredths place. So you look at the neighbor, and then that rounds to 3.94. So fraction, centimeters, ratio and proportion. So centimeters on the top, inches on the bottom. centimeters on the top, inches on the bottom. So we were given 10 centimeters and then unknown inches. And then for 1 inch, there's 2.5. Okay, so cross multiply. So that's 2.54x equals to 10 times 1. Solve for x, you're going to divide this by 2.54, 2.54, and you get 3.94. Okay. Okay, example 13, we have 6 feet, 4 inches converted to how many centimeters? Round to the nearest tenth. So what we got to do is first convert everything into inches. Okay, so 6 feet times feet on the bottom, inch on the top. We know that 1 feet is 12 inches. And then 6 times 12, 1, which is 72 inches, plus 4 inches, that's 76 inches. Okay, now we know everything in inches, so now we can do dimensional analysis. So 76 inches times fraction, and then inch on the bottom, centimeters on the top. For 1 inch, there is 2.54 centimeters. And then we're going to double 1, it just disappears. So you're left with 76 times 2.54 over 1, and you get 193.04, but the direction says round to the nearest tenths. Um, okay, so what do you think? Round to the nearest tenth. Do you think our answer is going to be 193.0 because 0 is technically in the tenths place, but and then you look at the neighbor, it's not far beyond? Or do you think it's just 193 without any point zero? The correct answer is 193, right? You never include trailing, we don't include trailing zeros. So that could be tricky, right? Because even this doesn't look like it's round to the tenth, but we don't include trailing zeros, so we just have no choice to round it to 193 centimeters. Okay, ratio and proportion, so fraction, and then let's see here. We could put inches on the top, centimeters on the bottom, inches on the top, and centimeters on the bottom. So we were given 76 inches, and then our unknown was centimeters. And then for 1 inch, there is 2.54 centimeters. Cross multiply, it says x equals to 76 times 2.54, and you get 193. Okay, example 14. We have 5 feet and 7 inches converts to how many centimeters? Round to the nearest, and it doesn't say, but it says it should have said round to the nearest tenths. Okay, not hundredths, but tenths place. So first we got to convert everything to inches. So let's start with the 5 feet. So 5 feet uh, times feet on the bottom, inches on the top. We know that for 1 feet, there's 12 inches, and then 5 times 12 is 60. And then you have this additional 7 inch, so that's plus 7, that's 67 inches. Okay, now let's do the dimensional analysis. So 67 inches times fraction, inches on the bottom and centimeters on the top. So we know that for 1 inch, there's 2.54 centimeters based on the chart. Invisible one on with 67. Inches disappears, and then fractions, so you multiply across. So 67 times 2.54. Then on the bottom, it's 1 times 1. And then look at centimeters. So what's 67 times 2.54? That is 170.18. But the direction says round to the nearest tenth, so 1 is the tenth. Look at the neighbor. So that would be 172, so 170.2. Ratio and proportion, fraction, and then inches on the top, centimeters on the bottom, inches on the top, centimeters on the bottom. So we were given 67 inches, and then unknown was centimeters. And then for 1 inch, there's 2.54. So cross multiply, so 1 times x is x, and then it's 67 times 2.54. And you get 170.18, and then round to the nearest tenth, it's 170.2. Okay, example 15. We have to convert 36 centimeters and we have to convert it to inches, and we have to round to the distance that it should say round to the nearest tenth. Okay, so let's start with dimensional analysis. So let's see, 36 centimeters times fraction, centimeters on the bottom and inches on the top, invisible one. For 1 inch, there's 2.54 centimeters, and then the centimeters here, and then multiply across, so 36 times 1. And then on the bottom, it's 1 times 2.54. And you get 36 over 2.54. And you get 14.1732. It says round to the nearest tenth, so 1 is the tenth place. You do have to round it to 14.2. Okay, ratio and proportion. Let's see, you put centimeters on the top, inches on the bottom, centimeters on the top, inches on the bottom. So we were given 36 centimeters, x is our unknown, inches is our unknown, and then for 1 inch, there's 2.54. Cross multiplies, that's 2.54x equals to 36 times 1. So that's 2.54x equal to 36. So you solve for x, so you divide this by 2.54. 2.54. You get 14.17322. The direction says round to the nearest tenths. So 1 is a tenths place. You look at the neighbor, it is 5 and beyond, right? 7 is 5 and beyond. So you're going to round it to 14.2 inches. Okay, example 16. 22 centimeters converts to how many inches round to the nearest tenths? So we can just start with the dimensional analysis. We were given 22 centimeters times fraction, centimeters on the bottom, inches on the top. So for 1 inch, there was 2.54 centimeters, invisible 1. Multiply across, so 22, so the centimeters disappears. And then it's on the top, it's 22 times 1. And then on the bottom, it's 1 times 2.54. We get 22 over 2.54, and you get 8.6614. And then if you round to the nearest tenth, 6 is the tenths place, so it's going to be rounded to 8.7 inch. Okay, ratio and proportion, fraction, centimeters on the top, inches on the bottom, centimeters on the top, inches on the bottom, right? So we were given 22 centimeters. Our unknown is inches. What's the relationship between inch and centimeters? For 1 inch, there's 2.54 centimeters. Cross multiply, so that's 2.54x. And then 1 times 2 is 22. And then divide this by 2.54. And you get 22 over 2.54. You get 8.6614. And then the direction says round to the nearest tenth, so 6 is the tenth place. We do have to round to 8.7 inches. Okay, see, we could do a few more. I mean, I do a lot of problems, but if you really know how to, you don't have to watch the entire problems. A lot of these problems are redundant, so it's good practice, right? Okay, let's start with 17. We have 4 fluid ounce converts to how many milliliters? The direction says round to the nearest tenth. So we can start with dimensional analysis. We are given 4 fluid ounce times fraction, and then fluid ounce on the bottom, and then milliliters on the top. So we know that for 1 fluid ounce, there's 30 milliliters, and then fraction under 1, the fluid ounce disappears, and then multiply across. So that's 4 times 30 over 1, so that's 120 milliliters. Now it says round to the nearest tenths, but we do not add trailing zero, so it would be wrong if you say 120.0. Okay, ratio and proportion. So fraction, you could put fluid ounce on the top and then milliliters on the bottom. Fluid ounce on the top, milliliters on the bottom. So for 4 fluid ounce, there's an X amount of we don't know how many milliliters. And then from the chart, 1 fluid ounce is 30 milliliters. Cross multiply, so 1 times X is X. And then this is 4 times 30. That's 120 milliliters. Okay, example 18, we have 15 milliliters converts to how many fluid ounce? Round to the nearest tenths. So we are given 15 milliliters. We can just start with dimensional. 15 milliliters times fraction, and then milliliters on the bottom, fluid ounce on the top. Invisible 1 under here, and then for 1 fluid ounce, there's 30 milliliters, and then the milliliters disappears, and then you multiply across, so 15 times 1, and then on the bottom is 1 times 30. and you get 15 out of 30. Our units is going to be fluid ounce. 15 out of 30 is 0.5 fluid ounce. Now, the direction says round to the nearest tenths. 5 is technically the tenths place. But do we include this leading zero? Yes, we do. If you have a decimal, we did have a 0.5. If you have a decimal, you must include the leading zero. So you must include leading not what is it? Yeah, trail leading zeros are the zeros on the front, and then trailing zeros are the zeros on the bottom. We never include trailing zeros, so must include trailing. I almost said trailing zeros, but we must include leading zeros. Okay, so the key is if you have a decimal, you must include uh, leading zeros. I keep saying that, leading zeros. Um, but we never include trailing zeros. Okay, ratio and proportion. So fraction, and then milliliters on the top, fluid ounce on the bottom, milliliters on the top, and then fluid ounce on the bottom. So we were given 15 milliliters. Fluid ounces are unknown. For 1 fluid ounce, there's 30 milliliters. Cross multiply, so that's 30x equals to 15 times 1. So that's 30x equals to 15. And when we divide this by 30, you get 0.5. Last one, and we are done with this. Okay, example 19, 4 teaspoons converts to how many milliliters? And we must round to the nearest tenths. So we can just start with dimensional analysis. So we were given 4 teaspoon times fraction, and then teaspoon on the bottom and milliliters on the top. You could put an invisible one under the teaspoon. And what is the relationship between milliliters and teaspoon? Well, we know for 1 teaspoon, there's 5 milliliters, and the TSB cancels, and then you're left with 4 times 5 is 4 times 5 over 1, and then we have milliliters. 4 times 5 is 20 milliliters. Where it says round to the nearest tenths, but remember we don't include trailing zeros, so it would be wrong if you say 12 point, it would be wrong if you say 20.0. Okay, last step, ratio and proportion. So you could set it up like this. You could put teaspoon on the top, milliliters on the bottom, and then over here, this should be teaspoon, milliliters on the bottom. With 4 teaspoons, there we don't know how many milliliters, and then for 1 teaspoon, there's 5 milliliters. Okay, go ahead and cross multiply. So that's going to be x equals 4 times 5, which is 20. There you go. That's good. And yeah, that is converting converting metric system to the household and sometimes and vice versa. Okay, I will stop here.